Okay, we'll get started. Last talk of the day, stick with me. We're going to be talking today about, not that. Okay. Let's try this again. Hi everyone, last session of the day. My name is Chris Upplecker. You will see me all over our org. I do a lot of Kubernetes stuff, and today we're going to be talking about Git. More specifically, we're going to be talking about practically using Git. In the Kubernetes project, we use Git for everything. And not just our code, but also our documentation, our policies, our procedures, even things like KEPs, our Kubernetes enhancement proposals, our SIG definitions, even our access control is all done by Git. So no matter what part of the project you want to be involved in, understanding some very basic Git stuff is important. There are, excuse me, there's plenty of tutorials out there on the basic Git flow. We're not going to cover that today. So things like cloning, committing, pushing, branching, we're not going to cover those. What we are going to cover is what happens when things get a little bit sticky in your PR. How to go about when a reviewer asks you to squash your PR, what we're asking for there. Things like rebasing, resolving merge conflicts, opening a revert, and actually opening a cherrypick against Kubernetes. So if you want to, if there's a bug fix and you actually need to backport that into an already released version, how do you go about doing that? So before we get into it, I want to talk about some key principles that will tie all of this back together. These are things that may not be obvious on the surface when you're working with Git. So first off, Git saves everything you commit. Even if you think, oh, I've deleted a branch, or I have made a change that's really, really broken something, you can still turn back time in your Git history and fix that. You haven't actually deleted anything. So if you've committed it, it's there. You just need to figure out how to get back to that. Second, each commit builds on the previous one. So a commit and a particular commit SHA is not just talking about a specific diff of changes. It is also what was the previous commit before that, and the one before that, and the one before that. So each commit, in addition to being a diff of changes, is also a particular point in time on your repo. Again, going back to Git saves everything that you commit. Third, SHAs are unique in normal use. Don't at me, crypto nerds. I'm not talking about SHA-1 collisions or anything fancy like that. I'm saying, like, in your normal use of Git on your local machine, a SHA will be unique. Which, again, building on these previous principles, if you go in and change anything, like you change which commit a new commit is based off of, you're going to get a new SHA out of it. It also is helpful to remember because when you move to a specific SHA, if you're referencing a specific SHA, that is a point in time in history in your Git repo. So if you know, oh, if everything was working at a very specific commit or a very specific point in time, you can dial your repo back to that specific point in time and then fix whatever mistake that you may have made. Everyone breaks their Git repo. It doesn't matter if it's your very first time using Git or if you're a senior principal software engineer with 15 years experience, you will break your Git repo at some point. It's okay to ask questions, and you can fix it. There's always a way. Your data, as long as you've committed it to the tree at some point in time, your data and your changes are not lost. It's just about figuring out what you need to do to get back to that spot. So, enough of the slides. Let's do a few demos on some of these procedures, and we'll walk through them together. For the purposes of this demonstration, we're going to be working on my brand new fork of Kubernetes called Honkernetes. And we're going to be making a whole bunch of changes to this repo. So first off, we're going to take a look at just a very basic squash. So if I look at the log for this branch, you'll see the top 4 commits there are me making changes where I'm renaming instances of Kubernetes to my new project name, Honkernetes. So I'm going through and I'm making some changes. The first one down here, this one I give a very clear commit message, and then I have a commit message that says I'm doing more, and then I get a little bit more terse as the commit messages go on. These commits, maybe they don't need to be separate commits. Maybe I wanted to squish them all together into one commit so I have a clean Git history. So how do I go about doing that? We're going to use a command git rebase -i with the interactive flag. There are 2 ways now, you want to tell Git what you're rebasing on top of. What are the commits that you want to actually interact with? There's 2 easy ways to do that. Either you can look at a log like this and say, oh, it's 4 commits. So I want to go head 4 with the tilde in there. And that tells Git, I want to look at 4 commits behind head, which is at the top. This one is the head of my branch. The other way to do this, that gets you the exact same result, is picking the SHA that you want to rebase off of. So in this case, this SHA is the one that's 4 commits behind head. This is where my master branch currently is at. So I'm going to copy and paste that commit, and it brings up a interactive rebase. So in this interactive rebase, I can see I have 4 commits here. The first column here is a command. For all of them, the default is pick. I have the SHAs of all these commits, and I have my commit messages. When you're squashing, there's 2 commands here that are very commonly used. As you can see, Git actually lays out there's a whole bunch of different commands that you can do to do different operations. The 2 we're going to focus on are squash and fix up. The difference, they do the same thing with one exception. Squashing, what it does is it takes the commit messages and it actually inserts them into the previous commit. So in this case, if I wanted to squash all these into one commit and each of these messages was useful, I would change pick to squash. Or you can just use the first letter of that command. So I could change pick to squash, and then it'll go put them all into one commit. The alternative is fix up, which does the exact same thing except it discards the commit message. So in this case, only the first commit message is the really useful one here. So I'm going to change these to fix up because I don't care about keeping these commit messages. Okay. So I've done that. I've changed the command that I want to do. Now I'm just going to write. The rebase is done, and I can look at my git log, and I can see I'm now down to 1 commit. Very easy, very simple. Now this, if I had a PR based off of this branch, now I would re-push this branch up. I will have to force push that branch because I'm changing what the history looks like. When you do a regular push, it's only additive, and it builds on 1 commit onto your branch at a time. Whereas with a force push, you're basically saying rewrite the tree to this specific commit. In this case, I'm not going to push this anywhere. I'm just going to change back over to master. And I'm going to merge my branch into master. So now I'm asking me to write merge commit. That's fine. Merge it in. I'm done. So now, NoFF is, I don't want to fast forward the branch, I actually want to generate a merge commit. Git will be opportunistic, where it'll say, like, can I do a fast forward, which is I'm just going to build one commit on top of the next on top of the next, or do you want to actually create a merge commit that says at this point I'm merging the changes in. I'll show you what it looks like in the Git log. So there's actually here, we see this commit again, this is where master used to be. This is the commit that I just rebased and brought in. So I'm maintaining that SHA, and then this commit, this is the actual merge of those changes. And you can see in the log it says, I'm merging two branches together. I'm merging, it was previously the 9859E and the EE2A5. So I'm now merging those together into master, and this commit is now where head is. So let's say now I want to undo that. I didn't mean to do those operations. Here's another cool command. Git reflog. So what reflog shows you, this is the history of your repo. And you can see each command that I've done and how it has changed where head is. So this current one, I'm merging the squishy branch back into master. Previous to that, I rechecked out master. Previous to that, I did a rebase, both the start and the finish of it. And it shows each step in that rebase as it's changing what the tree looks like as it's going through that rebase. So if I go back and I want to go back to where things were when I had checked out, but before I had started my rebase. I have here head at 7, so it's 7 steps back, but I also have a SHA here. So I can, if I want to just look at that temporarily, I can git checkout that SHA, and now I'm back to where I was. So each step in there, even if I'm doing a change that like seems destructive, it's all in there, and I can go and roll back and view at any point in time what has happened to my repo every step along the way. So nothing I'm doing here is destructive as long as you've committed. The only time you need to be wary is when you haven't committed changes to the repo. So even if you are doing work on something and you're iterating, it's very helpful to just git add, git commit, and even putting in like a work in progress commit, so that you're saving each point in time, and then you can dial back to those if you end up making a mistake or wanted to look at like what things looked at previous to a new action you've taken. So I'm going to go git checkout back to master, and we're going to take a look at a rebase. So we have now master, we did this change where we did a bunch of renames in our repo. Now maybe we want to integrate those changes into a new working branch. If we're collaborating with somebody and we want to pull in their changes and bring them into our current branch. So if I look at the log for this branch, I still have this 9859E. That's where things were when I started like branching off. That's where master was when we started. This branch was based off of that, but I don't have any of the changes that I just made. I don't have the merge commit, and I don't have the change that actually came with a diff of I'm doing a bunch of renames of my project. I want to integrate those changes into my working branch because I want to see how those changes interact together. So now I'm just going to run a git rebase master. I'm going to leave off the interactive flag because at this point I don't need to go individually commit by commit. I just want to take my current branch and stick it right on top of where master is, what the commit of master is. So I'm going to run that, and I'm going to look at my log. So now I see in my commit history, I have where the squishy branch was, I have where master is, and now I have my new commit stacked on top of it. Rebasing is in particularly helpful when you have a very fast-moving repo like Kubernetes does, and you have a whole bunch of other upstream changes. Maybe changes that you are doing test and work normally on your local branch because you're behind where the Kubernetes master is. So rebasing, even if there isn't a conflict between the changes that you're making and other upstream changes, there may be other more complex software operations that are happening behind the scenes that are making now when our CI takes your changes, merges them on top of what it has in Kubernetes, now tests are failing, now they're breaking. So doing a rebase like this, pulling in what the current master is and doing a rebase on top, very frequent, very common operation if tests are failing upstream and you're not sure why. It's likely that you may need to rebase and bring in some upstream changes. So now we're going to look at a slightly more, actually going to bring this back to master, and I'm going to do another merge in of my rebase branch. Yes, I want to merge rebase, right, and I'm done. So now I'm going to look at my branches again. I want to pick out the resolve branch. So now I'm continuing to make changes to my repo. So I actually want to do git log. So now I have a new commit here. I'm going to show you actually what this commit does. So head -1 is I want to compare my current head of my branch to one commit behind it. So I want to look at just the last thing. So in this one, I am changing this line where I'm saying Kubernetes is hosted by the Cognitive Computing Foundation. I'm changing it to it's hosted by Honk CI, which is my new organization for my new fork of Kubernetes. However, as you'll see in a minute, this is actually going to hit a conflict, and I'll show you. So now, what if I want to do the same thing? What if I want to rebase this on top of master, but I'm going to get a merge conflict? So git rebase master, doing the exact same thing as I did before. Git is going to cough at me and say like, hey, there's actually conflicts now. Conflicts happen when the change you're making is also the same line or one or two lines above or below where there's context. Two different changes have now collided where they're changing the same part of the code base. Git doesn't necessarily know which one should win. So it's going to stop and it's going to ask you to go and resolve that conflict. Git diff. So this is the conflict. So the top one, this is where head is. So this is where when I'm rebasing on master, this is what the master line looks like. I've renamed the project, but still hosted by CNCF. The line below it is where I've changed who is hosting it, but the name is still Kubernetes. Git doesn't know how to resolve which line should win here, which line is actually more accurate. So it's going to stop and it's going to ask me to resolve it, which I can do very quickly. So when you're resolving it, the lines with the arrows and the equals, you want to remove those because that's like the Git metadata of showing you, okay, this is where head is, this is where your branch kind of differs. Now you need to pick and resolve. So I'm going to delete those lines. So now I'm left with this, and I'm going to edit it where I'm going to make the change again manually. And this is I need to manually tell Git, oh, what do I need this line to look like? What is the end result going to look like? Okay, this is what I want it to look like. I'm going to save the file. There. So now it shows this is what I want the file to look like. I'm going to add that. I'm going to follow, like it tells me right here, what do you want to do? So resolve all conflicts manually, mark them as resolved with add to, or remove to add or remove the file, and then git rebase continue. Add, continue, Now I'm going to look at my log again. So I've still got my commit up at the top. This is like the commit that specific thing is changing. I've also now successfully rebased it off of master, where I've got, seeing my history, I've got my first branch, squishy, that then got merged in. I've got where the rebase branch is, and then that got merged into master. Now I've got the head of my resolve branch with this one commit. And if I look at that specific diff, it shows now I've got my specific change. This is the one I want. So I've now successfully resolved that. And if I go back to master, resolve. Do I want to merge? Yes. Now I can look at my master history, and I can see now I've merged all of my branches into master. Master is now what I want. All of these actions, these are very common no matter what Git repo you're working in. And these are useful operations to practice because they do come up so often. And there's ways to, there's different resources that you can refer to if you don't end up doing these very often, but being comfortable with those core Git operations will help you no matter what area of the project that you want to get involved in. One last thing I want to show you that's very Kubernetes specific is I want to cherry pick a PR back to a release branch. Because we have a very specific way we want this done, we've actually developed a script that runs in our Kubernetes repo that handles this for you. Because our cherry picks, we have a whole bunch of things like release notes that are tied into every Kubernetes PR. And if you've ever opened one or you plan to open one in the future, there's a bunch of text in our pull request body that will tell you and explain to you what exactly we're looking for as far as, does this PR meet our release notes policy? Should it have a release note? What does that release note look like? So that when we publish a change log, we have details of all the major changes, the bug fixes, things that customers of Kubernetes who are running it, operators, what do they want to know about? So changing over here to a repo where I've now got these changes and I want to cherry pick this back. So I'm going to show over here. This is my PR where I'm renaming the project. So it's a bunch of specific changes that I've done. This has merged into master. This was the same kind of thing that I was doing in the very first where I'm like rebasing things. So I've got this commit, I've merged it to master. Now I want to cherry pick this back to a release branch. So the command that I've got here is hack cherry pick pull. The branch that I want to base it off of, in this case, which is upstream release 117, and then the end number where I've got number 1, that's the PR number. You can actually, if you want to put multiple PRs in there, you can string extra PRs together if you need to pick multiple original PRs back to the release branch at the same time. That can happen especially when you have like dependent changes or you have iterative fixes where, a feature was put in a specific thing, but then there's also a couple extra PRs that need to do to fix functionality or fix tests or problems. In this case, I'm just picking back the one PR. So when you run this, it does most of what it needs to do automatically. The things that are happening behind the scene is it's updating, pulling what a release branch looks like. It is merging it in a very specific way. And then it's actually going to open the PR for you directly against GitHub. What it's asking for right now is that confirmation of like, is this good? Is this what you want to do? In this case, I'm going to say yes, this is what I want to do. It's going to push that up to GitHub, and it's going to automatically open up, it's going to open up a PR, and actually links it here. and it populates which PRs you're actually picking back into this release branch. So this procedure, this script, is active in the Kubernetes repo, and if you're picking back multiple features back to a release, I should clarify, bugs. We have a policy around what exactly gets pulled into, gets backported into a release branch. It's usually security fixes, bug fixes, things that are going to harm Kubernetes consumers. We don't usually pick back features because we don't want to negatively impact anybody who's running and expects stability. There's a specific policy that SIG release has of like whether a cherrypick will actually be accepted. But this is how you open the cherrypick PR, and when you do it, when you open it, it actually gets marked as a cherrypick by our bots, and then it gets like sent through a specific review process for cherrypicks. But I wanted to show this one because if you end up working in the main Kubernetes repository, we have a very specific way we want you to do it, and that's why we wrote a script. This one is, again, very unique to us as opposed to the first 4 that were very general and will be helpful in whatever different Git repos that you want to work on. So, I know that's a lot of information. Here are some extra resources that if you need to refer back to anything that I've talked about, these are really good resources and more. So the first one here, GitHub/hub is GitHub's CLI tool. That CLI tool is actually required for our cherrypick script, and if you don't have it installed, it will tell you, hey, you should go and install it. It also lets you do some cool things like you can use that CLI tool to check out a PR directly with a GitHub URL. Like you don't need to mess around with remotes or anything like that. You can go git checkout and paste a GitHub pull request URL, and it will check out that pull request directly for you. One of my favorite resources, ohshitgit.com. Very quick, brief explanations of like, oh, I've made a mistake. How do I go back and fix it? A lot of the reflog stuff that I was showing, how the history looks, that is a really good resource for doing that. They also, the author of ohshitgit collaborated with Julie Evans, Bork, to create a print comic that goes into even more detail about how to fix even stickier Git problems in your local repo. Again, going back to the point that like, if you've committed something and it's in your history, you can go and fix a problem. You don't need to go necessarily the nuclear option of delete the repo and reclone it, or copy your changes out. Like there are ways to end up fixing things. Help.github.com, guides.github.com. GitHub has some great resources for both answering questions about how things relate to GitHub specifically, but also teaching you Git on your local command line, helping you feel comfortable with it. And git.case.io/community. That is where all the Kubernetes specific things reside, including our contributor guide, including details, like if you want to learn all the different steps that our cherrypick pull script is, or you need to know the syntax for that script. All our Kubernetes specific documentation is in our community repo. So, it would be very difficult to give me a microphone and tell me to talk about Kubernetes without touching on community. You've had a whole day of content here. But one of the most important things that we have that makes Kubernetes what it is our community. There is something that is true about every single person in this room. First off, we are all lucky to be here because you will not find a more friendly and passionate community in all of open source. You just won't. The other thing that is very true is no matter what your background, you belong here and you have something to commit to this project. So please, if you have questions, even basic things like Git that you think, oh, everybody knows that stuff. That's why I'm talking to you, is because it doesn't matter what your background is. Some people will know this. If you come from like a software engineering background, you might. But there's plenty of things to do in the Kubernetes community if you're not a software engineer too. We need all of your help. So please come together, let's build something cool. Thank you. think I do have like 4 minutes if anybody has any questions before ducking out to another thing.
Yeah, can you roughly explain what the Cherrypick script is? Yeah, I mean, just
So in very loose terms, what it's doing, it is confirming that the PR that you're referencing is a master PR. So like if you're trying to cherry pick something that's going into a different branch, like a feature branch or something like that, it'll say like, this is invalid, it's not a PR against master. It also makes sure that that PR has merged, that it has passed all the checks, it has successfully merged, and it is ready to be cherry picked back. It also allows us to order, again, as I was saying, if there's multiple PRs that have related changes, and I want to cherry pick all of them together, it will pull all of them, validate all of them, and then merge them in sequence. And then when it opens up the PR against our organization, it also confirms that there's the right release notes stuff. So in this case, I don't have any release notes because this was an example change. But when it's running against Kubernetes, it will go and it will actually complain to you, oh, you need release notes for this, or this particular PR was like for a feature, it's not eligible to be cherry picked. Like there's a bunch of extra steps that it does as far as verification goes to make sure that the things that you're cherry picking back to a release branch are valid and make sure that they merge in the right order.
How common is it that you'll need to cherry pick? Like, is that something that's happens all the time, or is it?
It depends on what you're contributing. If you're working on feature work, not likely, because feature work usually gets merged in and then it's fine. If you are fixing a bug, well, I know that's a lot of folks when they first come into the community. If they're looking at the source code, a lot of times it's because they found a bug or they're finding something that doesn't make sense. If it's impacting current production releases of Kubernetes and based on the risk level of that change, we have a release management team that does all that, and the PR and the bots that we have will tell you like, oh, you're ready to go and talk to that team. They assess based on the risk, is this worth bringing back? In a lot of cases, very commonly bug fixes. Yes, there are lots of bug fixes that we want to bring back into previous stable releases because, depending on the deployment of Kubernetes, not everybody can be on the absolutely bleeding edge of the brand new releases just for bug fixes. So again, depending on the area of Kubernetes that you choose to work or get involved in, it can be fairly common. Any other questions? Thank you so much.